Okay, we're recording now the lesson for today. We just defined I as being the square root of -1 because we started working these problems and we got stuck here. So we defined I as the square root of -1. So when we solve this problem, we get x squared equals -9. So we take the square root of both sides, and when you do, you get plus or minus. So x equals plus or minus the square root of -9. Well, -9 is just the product of 9 and -1, isn't it? We know the square root of 9 is 3. And we just defined the square root of -1 as I. So the solutions to this equation are plus or minus 3i. Yes, sir.
Why do we need an I to represent -1, like a square root of 9?
If we had not defined this, then we would be stopped on solving lots of different problems. And I has actually a good bit of application, and we're going to look at some of that application later on in engineering and electrical. And anyway, we'll get into some of that after we have a basic understanding of I. Okay, so we looked at our sets of numbers, natural numbers in the center here, that's your counting numbers. Then it adds in whole numbers and then integers. And then real numbers breaks down to rational and irrational. And now we have our complex, which consists of the imaginary, like we just got for those two answers, plus or minus I and plus or minus 3i, and complex. Now, complex is when we have a real part with an imaginary part. Now, I found this really super cool looking bin online. I wanted to share it with you. This is one that was shareable. It gave permission. But it's the same idea here. Here we had our 0. And when we add that in with our natural numbers, this is now our whole numbers. And when we add the opposites, now we have the integers. Rationals includes all of this plus our fractions. Algebraic is anything we can solve for algebraically. Real algebraically would just be those square roots of positive numbers. And then real. So all this is contained in real. And then going up this way, we have our imaginary. And then coming out this way, we have our complex. Now, doesn't this number look cool? E plus pi I. Okay, just to me. All right, so we're going to work on simplifying some radicals. This is the square root of -36, which you can think of as -1 times 36. What is the square root of 36? 6. What's the square root of -1? I. So this simplifies to 6i.
So we're just going to add I to this end of all of them?
Anytime we have the square root of a negative, it simplifies to I. Okay, so the square root of 20. Actually, this is the square root of -20, but we're going to think about the 20 just like we did last year. What is the largest perfect square that will divide into 20? 4. So we're going to break this into 4 times 5. But this time, we also have the -1. So what is the square root of 4? 2. Do we know the square root of 5? No, so it has to stay under the radical. What is the square root of -1? I. So this simplifies to 2i root 5. Everybody looks tired today.
I'm not tired, Miss Willoughby.
Except, oh, awesome. You don't need to be tired. Good. All right, square root of -7. Now, 7 doesn't really simplify, but we can think of it as 7 times -1. So this simplifies to I root 7. All right, now this one we can think of as -1 times 25/16. All right, we can simplify the square root of 25/16. What's the square root of 25? 5. What's the square root of 16? 4. What's the square root of -1? Okay, 5/4 I. Any questions about these?
How come the 5/4 would be the square root of the 7 would be?
We can take the square root of 25/16. So we do. This simplifies completely. The square root of 7 does not simplify. There are no perfect square factors that divide into 7. So square root of 7 is already simplified. So you do. So if it's something that has perfect square factors, like 25 is 5 times 5, 16 is 4 times 4. So if it has perfect square factors, we factor those out. Take the square root. Okay. Now, we've already talked about this. Complex form is the a plus bi form. So that means we have our real part and our imaginary part. So this is an example of a complex number. Now, if you remember, if you look back at either of our bins, doesn't everything fall within complex?
Yes.
And doesn't everything fall within complex?
Yes.
So right now, every single number you know falls within the complex number system. Every single number you know. And even the new ones you learned about today.
There are complex numbers, like simple
Okay,
numbers.
so all these numbers have to be complex. This one has a real part and an imaginary part. A real part and an imaginary part. Now, this is still complex. If you were having to name it, you would just call it imaginary. But could we think of it as being complex if we thought of it like this? Our real part is 0. Do you see how it falls within the complex? Okay. This we would consider, we could even call this an actual number, right?
Yes.
But specifically. But if we wrote it like this, do you see how we could think of it as being in complex form, a plus bi form?
Yes.
Yes, sir.
This may be a little unrelated, but if there's complex numbers, are there also simple numbers?
Have we defined a simple number? I don't think that there is a mathematical definition for a simple number. I'll look that up.
I thought all numbers went into
All right. Now, a conjugate of a complex. Today we're just naming the conjugate, and this may make you think of Spanish or, a different language. Today we're just naming the conjugate, but next week we're actually going to do some things with the conjugate. It's necessary. So to find a conjugate, all you do is negate the imaginary part. So that turns the imaginary part to its opposite when we negate it, right? Negate to make negative. All right. So when we negate the imaginary, the conjugate would be 2 minus 3i. If we just negate the imaginary, the conjugate would be negative 4 plus I. Do you see how the real number part doesn't change? Just the conjugate. Okay, so if we negate the imaginary, the conjugate would be 7i. There's no imaginary, so we'd actually never really use the conjugate on this. Any questions about the conjugate? Okay, open your geometry workbooks to page 296. This is our geometry workbook. We're back in it. And your homework tonight is out of your geometry textbook. Okay, if you forgot to bring it, here are the problems.
Oh, okay. Here's a nice question.
All right. So, in 1 through 8, you are filling in the bin. So, if you didn't bring your workbook, just draw 2 circles with a big rectangle around it, and place these in the most specific category you can put them in. Because we know they're all complex, but most specifically, what could you call it? Then find the conjugate, and we're only going to do 1 through 3 on here. Oh, actually, these are worthwhile. Let's go ahead and do them.
For number 7, is that a dot? It's a dot.
That's 6.492. 6 and 492 thousandths.
Are they gonna though if that's not the same page?
Huh? No, they're on 2 different pages, 296 and 297.
Okay.
This is in the textbook, right?
This is in your workbook
This says in 296.
of the geometry workbook.
whenever it's tough.
Yeah.
Sorry about that.
Okay, yeah, that's good. That's the exact same thing. Oh.
Oversteer.
296 and 297.
Correct.
Good.
So I guess more important question is to learn anything after this year.
Just be numb, right? Is there a different number that can pass in the class? Or is it just like not even a number anymore? It's just like supernatural.
There's combinations.
How's your place from?
Give us the transcendental numbers.
Okay.
How old you are?
Yeah, subject.
Yeah, I was really like, that's gonna be so like regretting going to
Everyone went in the other door. They don't have to go through the line.
Yeah, Chick-fil-A, like the one day I wanted to go eat Chick-fil-A for breakfast, it was the most disturbing experience of my life. Like all the cheerleaders were just out there, they're cheering everybody as they walked in and out.
Alright, so this is a complex number. It has a real part and an imaginary part. So it can't exist in either one of these circles. It has both. Okay, negative 17 is just an integer, and an integer falls within the real numbers. The square root of 7 is an irrational number, but that's not. It falls within the real numbers. 9i, that's just imaginary. 6 minus 5i, well that has a real part, excuse me, negative 6, and an imaginary part, so we'd have to place that in complex. Negative 7/8, that is a real number. 6.492, that is also a real number. And then the opposite of the square root of negative 25, well, the opposite of the square root of negative 25 would simplify to negative 5i, so it's going in here with imaginary.
I didn't really get stuff outside.
Okay.
Yeah.
Like when you started running, I was like, oh. I thought it was just
Okay. Now, this is so simple, it's almost mundane today. All you're doing is the opposite of the imaginary part. So it's quite simple. And then tomorrow we'll definitely be using those conjugates when we do
Tomorrow?
Well, aren't y'all meeting back up here for a little math?
No.
Okay, we'll do it on Monday
I'm
then.
meeting up all the baseball fields.
We'll do it Monday. That's fine. That's fine.
I gotta work.
I'll take you guys with a bunch of math.
Okay,
Working.
that's fine. Alright, so square root of negative 32. We're going to break down into 16 times 2 times negative 1. So it's 4i root 2. Square root of negative 18, we're going to break down into 9 times 2 times negative 1. Alright, so when we take the square root of 9 out, it throws a 3 out here. And when we take the square root of negative 1 out, we get an I out here. So we get 3 times 2 times I, 6i root 2.
That's what I got.
Okay, this one we can rewrite as or think of as, actually, hopefully you're going straight to the answer on most of these, is 1/3 I.
I literally have
Because the square root of 1 is 1, the square root of 9 is 3, and the square root of negative 1 is I. Now this one, remember it's the imaginary part that we do the opposite of. So this is 1 minus 3. Well, the real number part doesn't change, but the imaginary part changes to the opposite. Now, when we write our complex numbers, we should always write them in a plus bi form. So this form is actually incorrect here. This would be negative 4 minus 3i, and this would just be negative 11i.
That'd be positive 4?
No,
Or is that-
the number doesn't change. We just negate the imaginary
Oh, yeah.
part. The real part does not change. We negate the imaginary only. Okay, now next is adding and subtracting complex numbers, which I really don't have to teach. Can you guys tell me what we're supposed to do here?
Come on, like,
Add and
Yes,
subtract.
combine like terms. So in this case, those like parts are the real part with the real part,
6.
and the imaginary with the imaginary.
negative 2y.
Negative 2.
Okay, so when we find the sum of these two complex numbers, the sum of these two complex numbers is 6 minus 2i. Okay? Now, subtraction. When we were doing addition and subtraction of polynomials, what did we change subtraction to?
Addition.
We changed it to addition, adding the opposite, same thing here. So the sum of these two complex numbers gives us negative 2 plus 9i.
We're gonna have to multiply and divide these over.
Monday. Since nobody wanted to show up tomorrow, we'll do it on Monday. Alright, so let's give these a try. This is on page 304. Okay, so we're doing 1 through 4. And then skipping down to do 9 through 11.
See, like, I don't mind running, like, if it's easy, like, I'd never, like, run, like, on a constant basis. The best I think I've done is, like, a 6.
Okay, let's check them. Did you get 8i? Negative 13 plus 2i. 3 minus 4i.
Yeah.
8 plus 14i.
Yep.
5 minus 7i.
Yes.
Negative 1 minus 10i. And finally, negative 7 plus 10i. We're set. Then you know what you're doing. So your homework is out of that green geometry textbook. It's page 437, these problem numbers, and 444, these problem numbers. Now, you're probably going to have time to finish this in class. But before we do that, I'm giving back 2 things. The learning task from yesterday, and I'm also giving back your test.